सर इलास्टिसिटी तो सुनिए।
नहीं पता, चले
नहीं इलास्टिसिटी
यहाँ से शुरू करते हैं। डिफॉर्मेशन किसे कहते हैं? तो डिफॉर्मेशन बेसिकली जैसे कि नाम से समझ में आ रहा है, डिफॉर्म हो जाए। डिफॉर्म हो जाने का मतलब क्या होगा? डिफॉर्म हो जाने का मतलब होगा कि चेंज इन शेप। डिफॉर्म, चेंज इन शेप, ठीक है। If we define deformation, what we define here is change in shape due to the application of external force. For example, let's say we have a metallic piece or a metallic ruler, okay? Let's say a force is applied here. It is fixed from this end, okay? Then what happens next? Any ideas?
So the shape of the ruler changed permanently.
It would bend, you know? Now it depends how much force is being exerted on this. If you know it is a higher force or a larger amplitude of force is there. For example, बहुत ज़्यादा ताकत लगाई गई है. So for maximum force को नहीं लिखते, for stronger force, what can happen? This ruler can bend permanently. है ना? पूरा यूं हो जाएगा खुद से, फिर सीधा करना पड़ेगा इसको. But if let's say this bend is dependent on, let's say, a very weaker force, फिर क्या होगा? So if we have a weaker force, this could bend temporarily. पूरी सीधा हो जाएगा. As an example ले लेते हैं और इसके लिए rubber band. है ना? तो इसके लिए भी एग्जांपल हम ले सकते हैं. Let's say electrical wire. So it all depends on how strong or how weak your force is. So if an object is deformed using a stronger force, this concept or this process is studied in plastic deformation, in which an object is unable to regain its original position or original shape. Not able to regain original shape. But if we talk about a weaker force, so this would be an elastic deformation. So if we talk about elastic deformation, the object is able to regain its original shape. Beta, is this clear to everyone? Do you have any questions?
No sir.
So
नहीं सर, स्ट्रॉन्गर फोर्स समझाएंगे क्या होगा?
a higher amplitude force. अगर हम एक रबर बैंड लें और हम उस रबर बैंड को जो है क्या कहते हैं बहुत ज्यादा ताकत से खींचें, तो अल्टीमेट तो ये कि वो टूट जाएगा. लेकिन टूटने से पहले क्या होगा? तो थोड़ा सा बड़ा होगा नहीं? तो इसे मैं स्ट्रॉन्गर फोर्स कह देता हूँ. और अगर मैं उससे ज्यादा ताकत से नहीं खींच रहा अगर मैं उसे बहुत ज़्यादा स्टडी नहीं करना चाह रहा, हल्का सा मैं उसको जो है वो वीकर फोर्स होगी जिसमें वो ओरिजिनल शेप को रीगेन कर लेगा. Okay, is it clear?
Yes, sir. Jazakallah.
So let's move on. Let's say we have a spring. So consider this. मैं एक spring बना रहा हूँ. Okay. So let's say this is the original length of the spring. So since there is nothing attached to this spring, I can say this is the unstretched length. ठीक है. Let's say this comes out to be, हम इसे कह देते हैं L naught, any length. In another case, the same spring is attached to some mass, and as a result, what happens? The length of this spring increases. So let's say this becomes the stretched length. Okay, so we can label this as L. So what I can relate with these two cases is, if we have a stronger or a heavier mass, so this would lead to higher increase in length. Is this understood?
Yes, sir.
That means, let's say if I'm having mass as 10 kilograms, and if I'm having mass as, let's say, 50 kilograms, and if I'm having mass as, let's say, 100 kilograms. So most stretched case would be this, and least stretched case would be this. So we can create somewhat a proportionality. Now, what is a proportionality? It is basically a relationship. So I can create a proportionality that leads me to this conclusion that if I'm having higher or heavier mass, that means I'm having more force, that would lead to more stretch. So this becomes the force, maybe weight, and this becomes the stretch. Now, what is this stretch?
तो बीच में रिबन क्या है?
Sorry?
वो बीच में रिबन क्या है?
This?
Yes.
Proportionality.
Oh, अच्छा, proportionality.
So let's say if we compare this, let's say this was the original length up till here. So this is X. So mathematically, what I can write or what I can refer is X would be equals to L minus L. That is basically change in length. Is this thing clear?
Yes.
Wait,
Any
sir,
questions so far?
length one क्या लेंगे और length two क्या लेंगे?
Any
X
values. It
X
may be 1 centimeter, 1 meter, 2 meter, and then its stretch length
Okay.
can be 1.1 centimeter, 1.1 meter, 1.5 meter, anything. These are two assumptions
Okay.
that
Got
L
it.
is more than L naught.
Oh, okay. Jazakallah.
Okay. So what we are interested in is basically not mass, not length, but force and extension. So it is quite logical to infer this, that if we are using a heavier force along with a spring, so it has to have more stretched length, or it can show more extension. सही कह रहा हूँ, गलत कह रहा हूँ?
सही है.
So this becomes the Hooke's law. So Hooke's law states that, let me say this.
Wait, sir, ये कौन सी law बनती है?
Hooke's law.
Okay.
Okay. So the statement here is, within elastic limits, I can write what extension is proportional to load. So by extension, I mean to say stretch, and by load, I mean to say force. So let's say if you draw a graph, between extension and load, so what could it possibly be? Anyone? So let's say this is a graph where I
The
have
more the extension, the more the load.
load on x-axis and extension on y-axis. Let's say. Okay.
So the more the load, the more the extension.
What would be the shape?
सीधी line बीच में सीधी.
Straight line.
मतलब
It's a diagonal line, obviously.
yes.
Straight line. Yes.
Yeah.
Good job. So this straight line infers a direct proportionality. Now, what is this a direct proportionality?
Sir, it is directly proportional to
Yes.
extension.
If
like
one
the-
increases, the other also increases. So I can write f is proportional to x, and then I can write f equals some constant k and x. This constant k
Good.
is
Sir-
referred to as spring constant.
आपने
Yes.
कहा था Hooke's law within elastic limit extension is proportional to load, which is basically Hooke's law is also f ribbon x, right? F proportional to 2x, right?
Yes.
Okay. Right.
Next is, see, we are studying that, okay, force is proportional to x, and then there is some constant. So what is this constant? So this constant basically depicts or explains the nature of a spring, how strong a spring is. Let's say compare two springs, a spring in a ball point, okay, and a spring in a shock absorber. So do you believe that these two springs would be of same strength?
No, sir.
The answer is
No.
obviously no. This would be a very weak spring because we are using our thumb to stretch or compress it, and this is provides some other heavier job. Let's say it has to have be installed in some lifts, elevators, cars, maybe bikes, and all. So it has to perform a heavier load scenario. So basically, this spring constant helps us to identify how weak or how strong a spring is. So basically, if we are having a bigger value or a larger value of K, so it represents a stronger spring. If we have a smaller value of K, it represents a weaker spring. Okay.
Okay, sir.
Yes.
So now coming towards the units, force is measured in
Joules.
newtons.
Newton.
Newtons. So we don't know yet the units of K, so let's keep it that way. This was some change in length. So do you know the unit of length in physics?
Sir, meter.
Meters, excellent. So K would have a unit of Newton per meter, since this meter gets being divided here. समझ आती है ये बात?
नहीं सर, ये समझ नहीं आया ये K is equals to N over M.
F is basically what? Newton, X is in meters. So K would be Newton per meter. Is this now clear?
तो K निकालने के लिए न्यूटन और मीटर करना है.
Who is this? Mustafa.
Mustafa.
Beta, please, what is your question? Can you be more louder?
K निकालने के लिए न्यूटन और मीटर करना है.
Sorry, I still am unable to hear you.
K निकालने के लिए न्यूटन और मीटर करना है. Are you still unable to hear me, or should I write it in the chat?
See, when I say force is measured in newtons, so what does that supposed to mean?
Force का ऐसा unit is newtons.
क्या कह रहे हैं?
I'll write it in chat.
मतलब अगर मैं आपसे कहता हूँ तो force is measured in newtons, so what do you understand through this? Is Newton needed to calculate force? This is what you get.
Sir, he's asking about K.
Yeah, I know you are asking about K, but you need to answer what I am right now asking about. If I refer to you that force is measured in Newton, so you take it this way that
SI unit is
force
newtons.
has to be calculated through newtons, or you use F is equals
Yes.
to NA for that. You use F is equals to MA for that, or you use
Okay. समझ आ गया. Sorry.
Okay. So
Okay.
when I say K is measured in Newton meter, I mean to say it's the unit of K. I'm not saying K is calculated through this. Okay, if you want to calculate K, we use F over X. Okay. Then moving on to the other part. The most important part was within elastic limits. So now what does that supposed to mean? See, if we stretch anything up, it has to have a limit. No substance in this world can stretch infinitely. If you are stretching up a spring, it has to have a limit. If you are stretching up a rubber band, it has to have a limit. So every stretchable substance in this world offers us a certain limit. Okay, so we have to be in that limit to study this Hooke's law thing. If we are violating, if we are going beyond that limit, then there is no such thing as Hooke's law. Let's say if I'm having a spring here that can at most be stretched up till here. That's the maximum it can offer. So if someone pulls it beyond this, so now it gets deformed. And it won't now obey this. This becomes totally inappropriate to this. Okay, do we get this?
Yes.
Any question so far? So in physics, basically we have every law has a limitation. So what you can say the limitation of Hooke's law is,
Sir, I have a question.
it has to have been in an elastic limit. You are stretching up a substance, you need to maintain that limit. If you are crossing that limit, it goes, bananas. हाँ, बोलें क्या सवाल है आपका?
सर जब स्प्रिंग जो है डिफॉर्म हो जाता है फिर वो अपनी ओरिजिनल शेप को रिगेन नहीं कर पाता.
Yes, this is what I'm trying to say. what we can do is, we can use a ball pen, and we can always plug that spring out, and we can stretch it by our hands. So it becomes elongated. So that is where Hooke's law is now violated, because you are applying that force and it is not regaining its original position or original shape. So it is not now an elastic substance. It has been deformed. Okay.
Okay, sir. Okay.
Is it clear to everyone?
Yes. Yes, sir.
So if there was, a straight line graph between load and extension within this elastic limit, it was a straight line. What happens to this curve if, we move on to this part, deformed part? So what we observe on this graph is a straight line until that's the elastic limit, and after that it can go, be a curve. So this refers to the proportionality limit or the elastic limit. This is elastic and this is deformation or plastic behavior. If you ever see an extension load graph that is a straight line, you need to think, okay, Hooke's law is valid and everything now is valid, this is proportional and everything. But if you ever see a graph of load and extension, it sounds some sort of a curve. So you need to understand that, okay, this is not now elastic, this is something deformed. So I cannot use Hooke's law for this region. Am I understood?
Yes, sir.
Sir, but we can use Hooke's law for the first part of the straight
Yes,
diagram.
you can use Hooke's law until here, but not beyond this part, since that's the limit. As long as your extension load graph is a straight line, you can very conveniently use Hooke's law. But beyond that, you can't. Okay?
Yes,
Is
sir.
that understood to everyone?
Yes.
Yes, sir.
Any questions?
No, sir. No, sir.
Okay. Now what we intend to study is the last part of this chapter, since this is a very small chapter, that is combination of strings. So springs may be connected in two different ways. We may refer to as parallel combination or a series combination. A parallel combination of springs would be, let's say, this was some spring supporting some mass. And if I intend to have a parallel combination here, I can have, two springs hung across a mass M. So this is the parallel combination of springs. But if we talk about series combination of springs, so let's say this was a single spring initially, and then a series combination would something like be this. Okay, so now let's discuss what would be the possible effect of this combination and this combination. If we talk about with a parallel combination, we believe that spring gets a bit stronger or K increases. Now, how is that supposed to, or what is that supposed to mean? See, a single mass was supported through a single spring. So maybe there was some extension. Let's say this was some extension up till here. But now just imagine if I am having Where was I? So if let's say we replace the single string with two strings, okay, so what can happen now? Just think.
Sir, load will increase without increasing the extension.
So there would be an extension, but it would be some less or some lower extension than this, you know, because now the same weight is supported through two strings. So it helps so what I can say is two springs, they can provide more strength in holding up that weight. And as a result, what happens next is that spring combination allows an extension to a smaller extent. You know. So let's say if extension was 5 meters here. So extension must be now 2.5 meters here if I'm having similar identical springs. You get this part?
Yes.
Any questions?
Wait, sir. So, what will hold more? A series of strings, or will a parallel strings hold better?
See, in physics, what we believe is no process is good or no process is bad. The only thing is the requirement. If we are doing some support that requires a parallel combination, so that is recommended. If we are doing some uh, physical process that requires a series combination, so series would be done. It's not about the question of efficiency or being better. It's only about the utilization. If we are, we have to use this parallel system. So we will be discussing the parallel concept. If we are having some series system, then we would be discussing some series. So what you guys need to know is what happens in parallel and what happens in series. We are not comparing parallel with series. We are only discussing what happens in parallel and what happens in series. Okay.
Okay, sir.
Okay, sir.
Okay. So can anyone imagine, or maybe you can answer, what happens here?
Sir, there is not much difference.
So K here decreases, and let's say this was some extension of 5 meters. This would offer even more extension because one spring would even further stretch the other. Okay, so I can have an extension of, let's say, 10 meters here if these are two identical springs.
So, sir, isn't this counteractive?
Can you be please a bit loud?
Sir, isn't this a bit counteractive? Why
Then
would
I
someone
can't
then
hear you.
use? I'll write in the chat.
You can write your question on chart if you are unable to, increase your volume. And yes, because again, there are certain requirements where we need more extension, and there are certain requirements where we don't need
Wait, sir. Question बता
more
देंगे?
extension. So again, if we are saying that it's counteractive, yes, it is exactly opposite to what happens in parallel, but it's not something bad. It's not something useless. It is being utilized in certain physical balances, in certain weighing devices. in certain measuring instruments. So it has to have a lot many applications. So it's not about the utility.
Sir, what
It's
was the
only
question?
about the requirement. जी बोले क्या बोल रहे हैं? So, okay. Any questions?
No, sir.
सर तो अगर
No, sir.
अगर पैरेलल स्प्रिंग में एक हाफ वो इलास्टिसिटी ऑब्जर्व हो रही है तो क्या सीरीज में डबल होगी?
Yes.
ये मुझे समझ में नहीं आया कि
Okay. So let's say if we were having a single string and that is stretched up to this point. Okay, let's say this was 5 meters. So now I am attaching two springs. So one spring is now attached with the other spring. So how can this become 10 meters? I can do the necessary maths here. I can start up with some derivations, some calculations, but I won't go into that because that's too mathematical for your size or your age. So what we can, just logically conclude
यहाँ
is
पे डबल हो गया.
this spring is now being stretched once and the other spring is now stretched again. So multiple stretching is there. So it becomes twice of what was it exactly, in the first case.
Okay, sir. Understood.
Any more questions?
No, sir.
Okay. So I'm ending this class and I would be sharing a worksheet. You are to attempt that by day's end. Would you be able to do this?
Yes, sir.
Okay.